Welcome back to chapter 28, amines, section number 3, amines as nucleophiles and their synthesis. By the end of this video, you will be able to explain why ammonia and amines act as nucleophiles, state how halogenoalkanes react with ammonia and amines, state how amines are prepared from nitriles, and state how aromatic amines are synthesized from benzene. Amines act as nucleophiles. Let's discuss this first idea. We have learned that the lone pair of electrons found on ammonia and amines in general will attack the positively charged deficient carbon in such a bromoalkane here. So amines, whenever they attack using their lone pair, whenever they attack a positively charged deficient carbon, they are acting as nucleophiles. What does the word nucleophile mean? Nucleophiles means nucleus loving. They love attacking positive nuclei of other atoms. Reactions of ammonia with halogenoalkanes. This is our second point of discussion. Ammonia can react with halogenoalkanes, but first, what are halogenoalkanes? Halogenoalkanes have the general formula RX, and they are like this compound, like bromomethane. So it's an alkane where one of these hydrogens is replaced by a halogen, and in this case is Br. X, which is the halogen, could be Br or Cl or F or I, iodide. Halogenoalkanes, we can call them haloalkane. It can react with ammonia. Ammonia is NH3. When they react together, they produce primary amine. Let's look at the two steps of the general reaction of such an interaction. In the first step, ammonia reacts with the halogenoalkane to produce this intermediate. Keep in mind that in this first step, the NH3 is reacting as a nucleophile here. So it will attack the haloalkane and attack its positive carbon atom. After that, this intermediate will react with another ammonia molecule. But in this case and in this step, this ammonia molecule is not acting as a nucleophile anymore. It is acting as a base, and we know that Bronsted-Lowry bases, they are proton acceptor, so they will accept a proton from the RNH3+, and this RNH3+ will become RNH2, which is our primary amine, and the ammonia acting as a base will gain the proton and will become NH4+ X-. Let's take a real example of a real compound for you to understand it clearly. Let's take bromomethane. This is our halogenoalkane. Bromine is more electronegative than carbon. That's why it carries a negative dipole, and that's why carbon carries a positive dipole. When it reacts with ammonia here, which is acting as a nucleophile in the first step, what will happen? What happens here is that the electron pair found on the ammonia, it will attack the electron deficient carbon here, and it will break the bond between the bromine and the carbon, as you can see. Then a new bond between nitrogen and carbon will form, and it will become like that. Why the nitrogen now of the ammonia is carrying a positive charge? Simply because it lost electrons. Now it has more protons than electrons, so they have more positive charge than negative charge. What will happen to the bromine it lost at the beginning? It will go aside as Br-. Now, what will happen in the second step? In the second step, the intermediate that we got in the first step, it will interact again with another ammonia molecule, but in this case, the ammonia molecule is not a nucleophile anymore. Now it is acting as a base. So what will happen here? If ammonia is a base, it means it's a proton acceptor. So absolutely, it will attack one of the protons carried by the previous intermediate and will take it from it. So this what will happen. The bond between the nitrogen and the hydrogen here will break down, and this compound will become like this. It will become CH3NH2, and the NH3, which is acting as a base, will gain the proton lost and will become NH4 plus, and of course the Br minus will stay there.